For this second set of problems, we're going to talk about two specific examples. One where we have an inclusive setup, and then one where we need to actually use the complement to figure out the probability of something. So first up, let's look at this problem where we have inclusive issues. Okay, so what we're looking at is a survey of 1,560 juniors and seniors. 840 were seniors and 630 read a daily paper. And only 215 of the paper readers were juniors. What is the probability that a student was a senior or read a daily paper? Okay, so what we can do to get started is we can just make ourselves a nice looking Venn diagram. Okay, so there's one circle, here's another circle, and then actually I'm going to make a box around this whole thing because that'll help us out a little bit too. Okay, and so in my box, well, let's slide this guy up a little bit. There we go. Okay, in my box, what I'm interested in is the probability that a student was a senior or read the paper. So this first one is going to be senior. And the other item is read the paper. For all of the students in this whole area, we can include 1,560 students. In other words, whenever I set up a set of probabilities, my denominator is going to be 1,560. Okay. So of those 1,560, I know that 840 are seniors. So I'm going to write 840 right here. And then I also know that 630 read the newspaper. Okay. But we need to figure out where is that overlap between seniors and those that read the paper. Well, if we know that only 215 of the paper readers were juniors, I'm going to write 215 in here. And so if I have a total of 630 paper readers, that means that there's an additional 415. So I'm going to write this vertically. 415 in here that are seniors because everyone else are juniors. 415 plus 215 should give me 630. Okay, so now we can cross that out since we know what we're working with. On the other side of things, if I have 415 people that read the paper that are also seniors, that means that the total over here is going to be 425. Because when I add 425 and 415, I get 840. So what I want to figure out now, what's the probability that a student was a senior or read a daily paper? Well, that's going to be 425 plus 415 plus 215. So 415 plus 215 is 630 and 840. That puts me in at 1,055 over 1560, or about 67.6%. Okay, there's the first problem. Let's look at another one. All right, on this one, let's say that each of 6 students randomly chooses a butterfly from a list of 8 types. What is the probability that at least 2 students choose the same butterfly? Well, to address this, what we're going to have to look at is called the complement. And the complement in probability speak is 100% minus the event that something is not going to happen. So we can call this the not event. Okay, and not, bad joke. I cracked myself up. Okay, so what we're looking at is 100% minus the not event, and that will tell us what the event is. Okay, so in this case, I'm going to do 100% minus, and instead of percent, I could just do 1 minus. Okay, now we need to figure out what this not event is. So let's set up some math over here. So let's say I have 6 students. Student 1, student 2, student 3, student 4, student 5, and student 6. And this student can choose any number of from any number of butterflies, and if they have 8 to choose from, they'll just choose one of 8. Okay, next student. Well, how many choices does that student have? Well, they have 8. And the next student after that, they have 8, they have 8, they have 8, and they have 8. So to figure out the total number of possibilities, I'm going to do 8 times 8 times 8 times 8 times 8 times 8, or 8 to the 6th. That's my first number, 8 to the 6th. And what that means is that's the total number of possibilities for choosing a butterfly. Okay, now, when I'm looking at specifically 6 students randomly choosing a butterfly from a list of 8, that's going to be N, P, R, where N is 8. So 8 choose R, and R is 6. 6 chosen from 8. And 8p6, well, that equals 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over, and then this is going to be 2 times 1. And what we just did right here is we did n factorial divided by n minus r factorial. The cool thing though is I can cancel out this 2 and this 2 and this 1 and this 1, and this number that I come up with is going to be 20,160, and 8 to the 6th, well, that's going to be 8 to the 6th, 262,144. In the end, what I ended up doing here, let's give ourselves like a little answer box, is I do 1 minus this possibility, which is a fraction, and I end up with about 92%, or 0.92. And that's the likelihood that at least 2 students choose the same butterfly.